Alright, we have learned how to solve systems of equations by graphing, and today we're going to learn how to solve them using substitution. So we're going to learn how to solve them algebraically and then determine whether the system is one, infinite, or no solution. This is just a review. A system of equations is two or more equations. You will have no solution when the lines are parallel. These lines will have the same slope but different intercepts. One solution is when the lines intersect exactly once. And to determine this, all you have to do is look at the slopes. If the slopes are different, then you know eventually those two lines will intersect. An infinite solution occurs when you have one line and then the second one graphs as the same line, and this will occur when you have the same slope and the same intercept. The substitution method, the first thing that you're going to do is to choose a variable to isolate or solve for in one of the equations. Your second step, you will substitute for that variable into the other equation and solve for the remaining variable. At the end of step 2, you should have like x equals 3 or y equals 12, where you've solved for one or the other variable. Step 3, once you know what the variable is from step 2, you will substitute that into either of the original equations and solve. And step 4, you'll check your solution for both equations. So our first example says to solve using substitution, and this one's pretty easy because it already tells you what y is. So you've actually done step 1 and step 2. So step 3, we're going to substitute that 3 in for y in the other equation. So it will read 3 equals negative 2x plus 4. To solve this, we subtract 4. These 4 subtract out, and you get negative 1 on the left side equals negative 2x. To get x alone or isolated, we divide by negative 2. These divide out, and you are left with 1/2 equals x. So here, because we got an answer for x and an answer for y, it means that you have one solution, and it occurs at 1/2, 3. And what that means, if we were to graph those two original lines that we were given, that they would intersect at 1/2 and 3. Your second equation is, or second example is, I like a little bit better because it has y, or you have two equations with slopes. So you know eventually at some point these two lines are most likely going to intersect. And step 1 says to find a variable and isolate it. Well, y has already been isolated, so we're going to take all of what y is and substitute it in for y of the second equation. So we're left with 3x plus 2, and we're going to replace that y with all of the other y in the other equation, which is negative 2x plus 4 equals 1. Then we solve this equation first by distributing the 2 to both terms. So we get plus a negative 4x, or just minus 4x, and then plus 8 equals 1. We combine like terms, and you get negative 1x, or just negative x, plus 8 equals 1. To solve this, we subtract 8. These 8's subtract out. You're left with negative 1x, or negative x, equals negative 7, and then last you divide by that negative 1, and x equals 7. So once you have this value, you're going to take that and substitute it into either equation. I'm going to actually go into the top equation for x because y is already solved for. So I'm going to go y equals negative 2 times the x value, 7, plus 4. And then we solve that. Y equals negative 2 times 7 is negative 14, plus 4 is negative 10. And you have one solution at 7, negative 10. Now, the last thing that you're going to want to do is you're going to want to check that solution in both equations. If it doesn't work in both equations, then it's not the correct point. So we try the top one, and I'll do it over here. In the top one, we're going to put negative 10 in for y equals negative 2 times x. X was 7 plus 4. Now we've kind of done this already. We get negative 10 equals negative 14 plus 4, which is negative 10. So we know it checks in the top one. In the bottom one, you're going to replace that x and y again So 3 times 7 plus 2 times the y value, negative 10, equals 1. And we'll solve it. This is 21 plus a negative 20 equals 1, and 21 plus a negative 20 is 1. And because it checks, we know that our solution is correct. Okay, our third example. Again, you're going to want to look to see if there's a variable that's already been solved for. Here, x has been solved for. So we're going to take all of x, put it into x of the second equation, and it will read 3y plus 9, and we replace that x. And then the rest of the equation plus 2y equals negative 1. And we'll solve this by combining like terms. 5y plus 9 equals negative 1. Subtract 9. 5y equals negative 10. Divide by 5. And y equals negative 2. Then you're going to take that negative 2 and replace it into either equation. I like to take all of this and put it into the first equation because x is already by itself. So it'll say x equals 3 times negative 2 plus 9. So here x equals 3 times negative 2 is negative 6 plus 9, and x equals positive 3. So we end up getting one solution located at 3, negative 2. Now you want to check this to make sure it's true. So we put these values into the top equation. So we have 3 equals 3 times negative 2 plus 9. And we solve this side. 3 times negative 2 is negative 6 plus 9 is 3, so it checks in that one. We check it in the second one. X, which is 3, plus 2 times negative 2. We're going to see if this equals negative 1. So we solve this left side. 3 plus 2 times negative 2 is negative 4. So you get negative 1 over here equals negative 1. And because this is true, it means that our answer, our solution, is correct. Now we have a couple special cases. The first one we're going to look at, we're going to use our substitution where we take all of this and put it into the x of the second equation. So we have 2y minus 1, and then minus the 2y equals 1. And right here when we combine like terms, 2y minus 2y is 0. So our variable is eliminated and we're left with negative 1 equals 1. If this happens and you lose your variables, then you're going to look at this statement. This says that negative 1 equals 1. We know that that is not true, so we get a no solution. That means our lines are parallel, and they will never cross. Okay, on our second special case, you're going to do the same thing where we take this and put it in for the x here, so it'll read 2y plus 1. We'll subtract the 2y equals 1 right here. And combine like terms, these subtract again out, and we're left with 1 equals 1, and that is true. So because it's true, that means that we have infinitely many solutions that will make our statements true, or that will make our equations true, and that means that you have the same line that will graph as the same line. Okay, I have a couple questions. Can you solve 0 equals 3x? Yes, you can, by dividing by 3. And we get x equals 0 divided by 3 is 0, and this is part of a solution. I have some of you guys that will see that and think that it cannot be solved, but it can. The next question says, can you solve 0 equals 3? And this is no. And this is where you're going to get a no solution, when your variables are gone and your statement is no longer true. Okay, our last example is an application, and it says Marianne sold 20 necklaces and bracelets at the craft fair. She sold 3 times as many necklaces and bracelets. How many of each did she sell? I would like you to define your variables first. I'm going to define them as B for bracelets and N for necklaces. And then you're going to go to the hardest part, which is to set up your two equations. So it says she sold 20 necklaces and bracelets. To write that, we'll say necklaces and bracelets. And she sold a total of 20. The second equation will come from that second statement that says she sold 3 times as many necklaces as bracelets. So she sold more necklaces. So I'm going to go necklaces equals 3 times the bracelets. And then we'll use our substitution where we put this in for n. We get 3b plus b equals 20. We combine our like terms. 3b plus b is 4b equals 20. Divide by 4 to both sides. And b equals 5. Once we know that b equals 5, then we're going to take all of that and substitute it into either equation. I'm going to take it back into that equation. And it will look like this. N equals 3 times b. b was 5. So 3 times 5 is 15. And we will write our solution like this. She sold 15 necklaces and 5 bracelets. All right, good luck with your assignment. It is the worksheet Solve Systems of Equations by Substitution.